Hey guys, please let me know if you can hear me before I start, please. All right, great. Okay, so I have one or two questions here that I want us to look at. Um, so hopefully you all are seeing this on my screen here. So what we want to do, I want to do a construction. So using a ruler, a pencil, and a pair of compasses, we want to construct this triangle here. Now, in this triangle here, we have our length BC. Okay, we have our length BC. We have our length AB, which is 6 cm. And we have this length here, AC, which is 8 cm. So first of all, when you have to do a construction, my suggestion to you guys is to do a little sketch first before you actually construct anything. So we have BC is 10. So let's see. So this is BC here. Right, we just do that quick sketch first, right? So BC is 10. AB is 6. Right, so AB is 6. Right, and then we have AC here, which is 8 cm. Right, so that's as much as we know here. Right, now what we're going to do, we are going to attempt to draw this here, but we are only going to use a ruler, and we're going to use a compass. So we need a ruler to measure our lengths. We also need a compass in order to measure as well. So since I've already drawn the sketch, the first thing I'm going to do here, I'm going to draw a line that is going to be 10 cm long. So typically what we do, we draw a line that is longer than 10 cm, right? So that's step one. We're going to draw a line longer than 10 cm. You're going to take your compass and you're going to open that compass here to a line of exactly 10 cm. Okay, so that's 10 cm here. So the first thing we do, we are going to draw an arc so we can indicate exactly where our 10 cm is. So normally we draw two arcs here. So this is just one. So we come on the side here now and we draw a second arc. All right. So that there represents 10 cm. So what you're going to do, you're going to label one time. So you're going to put this here as B. You're going to put this here as C. And you're going to put this here as 10 cm. Now the next thing I'm going to do here, I need to draw. We go back to your little sketch here. We have a length of 6 cm and a length of 8 cm. So let's open the compass. Let's open the compass to a length of, first of all, 6 cm. So this here is 6 cm. So since you're constructing a triangle here that only has lengths, we have no other angle or anything like that. We just have lengths. What you're gonna do, you're gonna draw an arc here. So we know at any point along this arc from the point B, that's gonna measure 6 cm. Okay. Next thing we're gonna do now, we're gonna do the same thing there, but we're gonna do it for the 8 cm now. So in this case here, let's open this compass here to 8 cm. So that's 8 cm, right? Let's put this down here now. Then I'm going to come to this point C here. And then what we're going to do, we're going to draw an arc here. So any point along this arc from the point C is going to have a length of 8 cm. So the next thing we're going to do, we're going to take our ruler. We're going to draw a line going this way. So in this case here, we have this. And we're going to draw a line here. Next thing we're going to do now, we're going to take our ruler again. We're going to draw a second line from the point C here. Right? And it has to pass through this point of intersection here as well. So it's going to be this. So that's our second line here. So let's do some labeling. So in this case here, this length here is going to be 6 cm. Right? This point here is actually A. That point is A. And this here is 8 cm. Okay, so that's the first part there. We use a ruler, a pencil, and a pair of compasses to construct this triangle here. The next thing we want to do, we want to measure and state the length of angle ABC. So ABC, in order to do that, you need a protractor to measure angle ABC. So if we come across here, right? Am I reading that correctly here? All right, so what I'm doing here, I'm going to measure that angle there. So if I measure that angle there, that looks like it's about 50. That's about 50. How much is that? That looks like about maybe 54 degrees, right? That's probably about 54 degrees. So you have to measure that angle there. So this angle here is about 54 degrees. Right, now let me just check that to make sure that's correct. Can kind of right, so yeah, calculation says it's about 53 degrees, but yeah, so that's an approximate measure for my angle there. Okay, so you use a protractor if you want to measure that angle. And then for the last part, we want to complete the diagram to show a quadrilateral CABD, right? CABD, where CD is equal to CA, CD is equal to CA, and BD is equal to BA, right? So you want to complete a quadrilateral. Now we have ABC, okay? So that means that D should be somewhere in this vicinity here. But we're doing it in such a way that CD is equal to CA, right? CD is equal to CA, and BD. So something is a little fishy about how they have this written, because this is a CSEC question, by the way. But we have CABD, right? Now CABD, unless this point D is somewhere here, right? CABD, CD is equal to CA. And something looking a little fishy about this part here. So I'll just leave out that part for now. Not going to waste too much time on that. All right. So this is how we do a simple construction. Okay. Right. So this is just one example of a construction here. I'm going to do a next one here. I'm going to do a second one. In the second one here, we have, let's see, which one should I do? Okay, yeah, I'll do this one. Okay, in this one here, we want to use a ruler, a pencil, a pair of compasses. And what we're going to do, we're going to construct triangle PQR, where PQ is 8 cm, PR. Okay, so again, do a little sketch. So we have PQ is 8 cm. We have PR is 6 cm, and angle P is 60 degrees. So basically, this is what's happening. We have a 60-degree angle here. This is PQ. This is what, R. So PR is 6 cm. So we're constructing a triangle. In this triangle here, we know what one angle is, and we know two sides. Okay, so let's start with that. So again, you need a ruler. Okay, we need a ruler to do this. And we're going to draw a length of 8 cm. So the first thing you'll do is to draw a line that is longer, right? That is longer than 8 cm. So let's shift this here a little bit. Let's take our compass, because we need to mark off exactly where 8 cm is. So you're going to place your compass against your ruler, and you're going to open this here to 8 cm, right? So that's 8 cm. So you're going to come to one end here, all right? You're going to draw an arc. Right? And in this case here now, we're going to come to the other side now. We're going to draw a second arc here. So this clearly shows where this line segment starts and finish. So this here will be P. This here will be Q. Right? And all we want to do now, we want to construct a 60-degree angle. So you have to be able to construct a 60-degree angle, which is very simple to draw. All we need to do is place our pointy part of the compass here. And what we're going to do, we're going to draw an arc here. So you're going to draw an arc here. Using that same opening, you're going to place the pointy part here now. And you're going to draw a second arc here. Right? You're going to draw a second arc here. So I can use that point P, right, as this point here. And that point of intersection of the two arcs, right? So in this case here, right? Now I don't know the length. I didn't measure the length as yet. So let's just let's draw a line from here to here, right? So that angle there that I have there is now 60 degrees. So this angle here is 60 degrees. And then what we want to do now, we want to measure, right, 6 here. That's what you want to measure, 6 here. So let's pull this ruler again here. And let's take compass. We're going to measure 6 here. So place this along this here. And you're going to open this compass to 6 here. Right, so that's 6 cm there. And then all I need to do is to place this here at this point here. And then all I'm going to do here is do this. Right, so that 6 cm is almost on that same arc that we just drew actually. Right, so that's our 6 cm there. So all I need to do is to take my ruler. And we're going to start at the point P. Let's rotate this here. Right? And this line here will complete our triangle. Okay, so this here is PQR. So PQ was 8 cm. And this here is R. So this R here is going to be 6 cm. Okay, so that's our triangle here for the first part. Triangle PQR is drawn here. Now they said in part B that the line segment RX is perpendicular to PQ. It's perpendicular to PQ. So RX is perpendicular to PQ and it meets PQ at the point X. Now let's go back to our sketch here. This is what they say. They're saying that a line drawn from R is perpendicular to PQ and it meets here at X. That's what we have here. So what we are doing, we are constructing a right angle from the point R towards the point P. Now, this is actually written in the syllabus. We have to be able to do this. So to do that, all we do, we use a compass again. And this is what you need to do. You're going to take the pointy part of the compass and we're going to place it at the point R here. Now, what needs to happen is that we are going to intersect, or we're going to cut this line PQ, right? So we need to make sure that we are able to cut this line PQ here. Okay, that's step one. Now, let's draw that arc here. I'm going to use a different color here so you'll see. So you're going to make that cut, that line PQ at 2 points. Then I'm going to take my compass again with the same opening. And what we're going to do here, I wonder if I can remove this. Yeah, let me remove this. Right, I'm just trying to get more space so you see what I'm doing here. So what you're going to do now, you're going to draw an arc here. Right, we're going to come here by this other point here. And we're going to draw a second arc. Right. So all I need to do to finish up that line there now is to simply draw a straight line. So we need a ruler for this one. So I'm going to turn the ruler this way. Right, we need to start at the point R here. We're going to start here and we're going to draw a line here. Okay, and that's it. So that's the line there, Rx. So you're going to label this as X here. So this is your X here. And this angle here is actually 90 degrees. Okay. So again, you have to be able to draw a line perpendicular to another line from a point. All right. So this is just one or two examples here with constructions. Okay. Let me go back here. How many marks again in paper 2? It depends on how you're doing in multiple choice, guys. Now let's look at one or two geometry questions here. What if you do question 1, 2, 6, and 7? So it really depends. If you do well in the multiple choice, all you really need to do is to make like about half mark in the paper 2 to pass. Okay, so we have PT RS not drawn to scale. It's a quadrilateral. And we want to determine, given a reason for each step in your answer. So the first part of this question here, we have, we want to work out RQT. So RQT is what? RQT is this angle here, right? That's RQT. Now, if we look at this carefully here, we have three lengths that are the same. Right now, they are telling me in the question that this length, okay, as well as this length here, they are the same. So therefore, this triangle here is an isosceles triangle. So this angle here is actually going to be the same 76 degrees. So if you want to work out angle RQT, so RQT is simply going to be 180 degrees minus 76 plus 76. So that's going to be RQT. So that's going to be 180 minus, open bracket, 76 plus 76. You're going to get 28 degrees. Okay, so this angle here is 28 degrees. So that's part one. The second part, we want to calculate angle PRT, right? Where's PRT? So when you get questions like this, try to put in your angles as fast as you're working them out. Now, what you're going to notice here is that this angle here, we can actually work that out. So that angle there, right, that blue angle there is simply going to be 180 degrees minus 28 degrees. So that's 180 minus 28, and we're going to get 152. So this here is 152 degrees. Now, if you look carefully again now, we have a triangle here that is actually an isosceles again, based on the fact that they give us the length of this thing here, right? So this length here, as well as PQ, they're the same. So what that means is that this angle here and this angle here is going to be identical. So if you want to work out this time PRT, so angle PRT is simply going to be 180 minus your 152, okay? And then we're going to have to divide that by 2 in order to get PRT. So that's 180 minus 152 divided by 2, and we're going to get 14 degrees. Okay, that's what we're going to get there. We're going to get 14 degrees. Okay. Right, some of you are working it out pretty quickly, right? So I see some people get 14 already. Okay, so yeah, that's 40. Now the next part here, they said angle SPT. You want to calculate SPT. Now again, you have to look at the diagram and see which angle are we working out here. So SPT, right? So we want to work out this whole angle here. This is SPT here, right? Because this is S, that's P, and this is T here. Now you want to work out that given that SRT is 145, where's SRT? SRT. SRT. Okay, so I need to put in some angles here before I do anything else. So this here is 14 degrees. This is also 14 degrees. Okay. Now they are telling me here that SRT, that's this angle here, is 45 and PSR is 100. So PSR is 100. So this here is 100 degrees. That's this. And we also know that SRT is 45. SRT is 145. So this diagram is definitely not drawn to scale, right? So this whole angle here, SRT, right? Make sure I put this correct here. Yeah, so that's SRT. So this whole angle here, right? That whole angle there is 145. Okay. So you want to work out what is that green angle. Okay, so first of all, we can actually work out, I can work out this little piece here, right? I can work out this little piece here if I want, right? That little piece there is going to be 145 minus 14 plus 76. You're going to get 55 degrees. Right? So this here is 55 degrees. So now the question wants us to work out angle SPT. So SPT is this angle here. Now if you look carefully, if I look at this quadrilateral here, P, S, R, and Q, it's a quadrilateral. And in a quadrilateral, all the angles or all the interior angles should add up to 360. So all I need to do to work out SPT, you're going to say 360 minus, you have to minus this 100 here. So you have to have 100 here. Plus, we need to remove this piece here, which is the 55 plus the 14. So that's going to be 69. So that's 69 degrees. Plus, we need to remove this one here, right? This one by Q here, that's 152. So when I work this out here, I'm going to get 360 minus, open brackets, 100 plus 69 plus 152. All right, and I'm getting 39 degrees. Okay, I know some of you are kind of moving fast here. I don't know if anybody get anybody gets this, right? Right, I see one person at 39. Yeah, 39 looking like the correct answer. Right, 39 looks like the correct answer. All right, let's try next one here. All right, we have this one here. We have two parallel lines, and we have some information here. So what we want to do, we want to work out, we want to find angle X. So if we look at the diagram here, you will notice that we have an isosceles triangle here, because this length, okay, as well as this length here is the same according to them. Now the first thing we notice that AB, that's this line here, and CD, they are parallel. So the first thing we want to work out is what is angle X. Anybody know what angle X is? What is angle X? Anybody know? I'm watching the comments here, right? Am I a Cohen fan? So Cohen is my partner. Relax. Right? Everybody's saying 28. Why are you all saying 28? Nothing wrong with 28. I agree as well. But you have to be able to give you a reason for your answer. So 28 is correct, right? 28 is correct. But what's your reason? Okay, so the reason is that they are alternate angles, right? They are alternate angles. Okay, so that's X. What about angle Y? We have to work out angle Y. So again, if you work out any angle, you should put it in one time. So this is 28 degrees here. That's 28. And we want to work out angle Y. So look at this here. If you want to work out angle Y, what you could do, remember you have an isosceles triangle here made up of Q, P, and R. That's an isosceles triangle. So what that means is that this angle here and this angle here are the same. So therefore, if I want to work out that blue angle, that is simply going to be 180 degrees minus 28 divided by 2. That's how we're going to work out that angle there. So that's going to be 180 minus 28 divided by 2, and you're going to get 76 degrees. Right? Make sure that's correct. So 180 minus 28 divided by 2. Yeah, that's 76 degrees here. So this angle is 76, and also this angle here is 76 degrees. Now, you can work out Y in two ways here. So what we could do to work out Y, you can either say 180, right, minus 76 will give us Y, which is 104, right? So Y is 104. Or you could have found Y by just adding the 76 plus the 28, right? So 76 plus 28, you should get 104 as well. That's an alternative way. So sometimes when you're doing geometry questions, there are more than one way of working the problem, right? There are more than one way of working the problem. So yeah, that's correct, right? 104. So this is 104 here. And the next thing we need to work out, what is angle Z. Anybody know what angle Z is? What if you are fling away the paper? Well, if you fling away the paper, I don't know how you're gonna mark anything though. I'll be going for a while, guys, right? I don't have any classes after, so I'll be going on for a while. So I know some of you all may have English B tomorrow as well, right? Okay, a lot of people saying 104, all right? A lot of people saying 104. That's looking right to me. So here's what's happening here. If this angle here is 104, it means that this angle here is also 104 degrees. And if that is 104, it means that this here is also 104. Okay? Now let me just show you a few things here that you need to be aware of when it comes to parallel lines. Let me explain one or two things here. So first of all, if I have a line here and I have a second line here, and these two lines here are parallel, meaning that if I extend them till infinity, they are not going to intersect, right? They're not going to intersect. So in this case, in this case here, what we're going to do, right? We are going to draw a transverse line here. Let me draw a transverse line here and show you what happens. So if I were to draw a transverse line here, right? So this here, let's call this a transverse line. That's what it's called. There are several properties here that you will need to be aware of. So first of all, if I have an angle A here and I have an angle B here, those two angles here, A is equal to B, and that is what we refer to as alternate angles, right? Those are alternate angles. So, you know, sometimes in school they will tell you look for Z. You have to look for Z, yes, but make sure the two lines that make the top and bottom of the Z, make sure they're parallel. Okay, so that's one rule that we need to know. Let's say we had something else like this. Let's say we had ABC. So let's say this is C, right? And let's say this is D here. We have another rule here that says angle A is equal to angle C, and that is what we call vertically opposite angles, right? Vertically opposite angles. Now this vertically opposite angles here applies to AC, and it also applies to B is equal to D as well. So these two angles here, they are vertically opposite as well. Now, apart from that, we have something called corresponding angles. So for example, angle B and angle C are equal to each other because they are called corresponding angles, right? Corresponding angles. Okay. We also have another rule inside here that we need to be aware of. So let's put in some more letters inside here. Let's say this is angle E. So let's say that's E, and this here is F. So angle A plus angle F actually adds up to give us 180 degrees. Okay, and this is what we refer to as co-interior angles. So these are just some rules that we have to be aware of when it comes to parallel lines, right? All right. Okay, so this is, like I said, these are just some rules we need to be aware of, right, when it comes to working out some angles. Let's have a look at this question here. Sometimes we get questions involving similar triangles. So for those of you who don't know what similar triangles are, let's say we have something like this, right? Let's say I have a small triangle here, right? So let's say I have a triangle here, and I have a larger triangle here. Right, so let's say this is A, B, and C. So we're talking similar triangles here. Right, and this is P, let's say Q and R, right? And this is also 90 degrees. Now these two triangles are going to be similar if this is what needs to happen for these two triangles to be similar. So this angle here must be exactly equal to this angle. This angle here must also be equal to this angle here. So all your corresponding interior angles must be identical in order for you to be similar. But not only that, if we look at this length here and we look at this length here, the ratio of PR over AC must equal to the ratio of QR, that's this length here, right, divided by BC, which is also equal to the ratio of PQ all over AB. All right. So we must have two conditions met for you to have similar triangles. Now, some of you all might be wondering, well, what kind of question are you going to ask on that? So just recently they brought a question along those lines. So let's have a look at that question here. Right. This is something similar to what just came recently. So we have the diagram below, not drawn to scale. We have AEC. Okay, so we have some information here. And they give us some lengths as well. Now, the first thing they want us to do is to calculate the length BC. Okay, now this here is the length that they want. This is BC here. Now, when we look at this here, technically you have similar triangles. And when I say similar triangles, it's like this. You see this small triangle inside here, this one, right? This triangle inside here is actually similar to the bigger triangle on the outside. So this triangle here, the one going all here, right, is what it's similar to. So if I want to work out, question wants me to work out the length BC. Okay, so if I want to know the length BC, this length BC here, right, has to be related to this length ED here. Okay, let's see what lengths I can use. Okay, in the triangle here, we're going to have to work out certain things. So first of all, I can work out the length AD. So the length AD is simply going to be 8 minus 3.2. So that's going to be the length AD. So 8 minus 3.2. And you're going to get 4.8 meters, right? 4.8 meters. Okay. Now, I want the length BC. So right? So if I want BC here, what I could use, I can just use Pythagoras' theorem to work out BC, because I have the hypotenuse of that right angle and I have the base. So therefore BC squared is simply going to be equal to 10 squared minus 8 squared. So BC squared is equal to 100 minus 64. So BC squared is equal to 36. So BC is equal to square root of 36, and therefore BC is going to be equal to 6 meters. Okay, so for that first part there, that's what we're going to get. Now they said explain why triangles ABC and ADE are similar. So again, you have to look at the interior angles. So this angle here in both triangles are exactly the same. This angle here and this angle here, they are the same. And well, we have the right angle in both of them, right? So all the interior angles are the same, and the corresponding lengths all have the same ratio in terms of how you're getting the lengths. Now the third part, we want to get the length of DE, right? So this here is 6 meters, and we want to get the length DE. DE is this length here. You all feel you can work that out? Right, and now just looking at, so some of you all asking about linear programming. I did a free session on linear programming just last week, I believe it was, or about a week and a half ago. That's a very good session for you all to look at. I basically explained how to do linear programming, and I did 2 questions there to help you guys. Okay, where is it? I should have it somewhere here. Right, so those of you asking about linear programming, here what? Look at it right here, right? I posted it in the chat here for you guys. Right, that's linear programming. right? Some of you all came in late. I did 2 construction questions previously, all right? All right, some people getting 2.4. Let's see if that's really true. Okay, so you want to get that length DE there. Now, this question, like I said, is based on similar triangles. So the ratio of the lengths are always going to be the same. Okay, so here it is. If I take the length BC, all right, and I divide that by the length DE, that's the ratio of the corresponding lengths of the 2 triangles. What should happen as well here is that the length AB divided by the length AD should give me the same thing. That's basically what we're saying here. Okay, so BC, all right, let me make sure I don't come off my screen here. So BC is 6. So this is 6 here, divided by DE, which is what we don't know. That's what we're trying to work out. Is given by AB, which is 8, all over AD. I'd worked out AD just now. I got 4.8. So this is 4.8 here. So if I want to work out the length DE, all I'm going to do here is to cross multiply. So if I cross multiply, I can say 6 by 4.8 is equal to 8 by DE. So therefore DE, so DE is equal to 4.8 multiplied by 6 all over 8. So this is going to be 4.8 multiplied by 6 divided by 8. And we're going to get 3.6 meters. Okay. Now, I think it's in the 2026 paper. There are a similar question, guys. So, yeah. So some people getting 3.6. Yeah, that's correct. Right? That's correct. Right, I see some people asking about speed time and distance time graph. So I did that. So this is the second session I'm having for the day, guys. So it's already on YouTube here, right? The first session I did a question on a speed time graph to work out acceleration and also to work out distance travel. Okay. Now I have another question here. And this question here is also based on similar triangles. So they said the diagram not drawn to scale. It shows OMN and its image OM prime N prime under an enlargement with center O and scale factor K. Right, so this is a question here involving an enlargement. So basically, we are taking OMN. So this triangle here is being enlarged. This triangle here. But the center of enlargement in this case is the point O. So we have a larger triangle being formed. They want you to work out what is the scale factor. So the scale factor K for 1 mark, all I need to do is to look at corresponding lengths. So we just need to take 16 and divide by 8 and you're going to get 2. So the scale factor in this case here is going to be 2. The next part, they want us to calculate the length OM. Where is OM? So OM is this length here. So if you want to work out the length OM, just like the previous question, you can use Pythagoras' theorem. So in this case here, we can say that OM squared, because that's the hypotenuse, is equal to 6 squared plus 8 squared. So OM squared is equal to 36 plus 64. So OM squared is equal to 100. So OM is square root of 100. So OM is equal to 10. And this is 10 cm here, right? OM is equal to 10 cm. So that's part 1. Surprising, CXC only giving us 1 mark for that. And the next thing we want to work out, you want to work out the length OM prime. So this here is 10 cm, but the length that they want me to work out is this length here. So again, just like we did in the previous question, we're going to write down the ratio of corresponding lengths. That's what you're going to do. So you can see that OM prime divided by OM is the same as saying, so we can look at N prime, M prime, all over NM, right? So whenever we're looking at similar triangles, we can write the lengths in terms of a ratio. So in this case here, OM prime is what we want to work out. So that's OM prime divided by 10 is equal to n prime m prime, which is 16, all over 8. So just like the previous question, we're going to cross multiply. So OM prime is equal to 16 multiplied by 10 over 8. So that's going to be 8 into 16, 2 by 10, and you're going to get 20 cm. Okay, so that's how we treat with a question like this. Right? Or you could have just taken the scale factor and multiplied by 2. Okay? Now, let's see everybody asking about circle theorems, right? Let's try a question here with circle theorems. I know people have issues with this. I've done many videos on circle theorems. Let's try this one here. Yeah, you can use the scale factor and just multiply the scale factor by the 10. Yeah, you could have done that as well. All right. All right, let's have a look at this circle theorem question here. So we have PQRS, 4 points on the circumference of a circle. We have QRS is 58 degrees. The first thing we want to calculate is SPQ. Okay, we want to calculate what is this angle here. Do you all know what that angle is? Right, somebody said they're going to skip all geometry questions. Right, the earlier session I did some questions on matrices, right? These are exam questions from all over the place, right? All over the place. People saying 122. Okay. So first of all, we have S, R, Q, and P. So those 4 points, they lie on the circumference of the circle. Whenever you have a scenario like that, it means that you have a cyclic quadrilateral. Now what happens here is that the opposite angles in a cyclic quadrilateral, they add up to 180. So therefore angle SPQ is simply going to be 180 degrees minus 58. And in this case here, we're going to get 180 minus 58, and we're going to get 122. All right, so that's our angle here. That's our answer for this part here. What about the second part? We want angle OQS. OQS is this angle here, right? That's our angle we're trying to work out. Anybody know how to work out that? I know I have some of my students here who are in my class. You all should be able to work that out. Yeah, I used to have that fear too. If my calculator is going to die. Yeah, I used to have that fear. Also, pens stop working, which has happened to me in exams already. Parabola graphs. Yeah, I did one earlier, actually. I did a completing the square earlier. We'll see. We have time, so I'll see what I can do. Right, I'll see what I can do. All right, people saying 58 by 2. Yeah, so first of all, there's a rule that says the angle, right, at the center, that's this angle here, is twice the angle at the circumference. So if this is a chord, right, so this line here, SQ is a chord. So if I make an angle on the circumference, that's this angle here, 58 degrees, right? And if I take the same ends of the chord and I come to the point O, I can calculate SOQ. So angle SOQ is simply going to be 2 multiplied by 58. So the angle at the center is twice the angle at the circumference. So that's 2 by 58. And we're going to get 116. So this here is 160, right? So this angle on the inside here is 116. But the question wants me to work out this piece here. What you need to recognize is that the length OS and the length OQ, both of them are the radius of the circle. So that makes that triangle an isosceles triangle. So if you want to get OQS, OQS is simply going to be 180 degrees minus 116 degrees. And we just need to divide that by 2. So this is 180 minus 116 divided by 2. And you're going to get 32 degrees. All right. So that's going to be 32 degrees. Okay. So somebody asking me the exam is tomorrow. Yeah, the exam is tomorrow, right? Right? So great. Some of you are getting 32. All right, let's see this one here now. Okay, so we have a diagram here, not drawn to scale. So I want you to pay attention to this. A lot of the diagrams that CXC is going to give you pertaining to circle theorems, they are definitely not drawn to scale. So don't look at the diagram and assume certain things, right? Don't do that. Only go with what is told to you in the question. Okay. So let's see. The point O is the center. Okay, so I know this is the center of the circle, so that might be important. What do we want to work out? So we have two angles inside here. We have a 20 degree and we have a 50 degree. So the first part, we want to work out HKL. Now, again, when you have these kinds of questions here, what you need to do, you need to first figure out exactly what angle are they asking me for here. In this particular case here, we want HKL. The middle letter will be the angle. So this is H here. All right. This is K and this is L. So what we want this angle here. That's the angle that we want. Okay. Now, usually they're going to ask you for your reasons. So first of all, anybody know what HKL is? What is angle HKL? What is angle HKL? Right, I've seen some people saying HKL. Also look at the angle to see the size of the angle, right? Also look at the angle to see the size of the angle. So in this case here, what you need to recognize is that you see this line here, HL, that's a chord. But look at this. If I take the ends of the chord and I go to the point G, I'm going to create an angle of 20 degrees. Now there's a rule that says that the angle in the same segment, they are equal. Now, if I take the same ends of the chord here, and that's H, and I bring it to the point K, and I bring this point L here to the point K, I'm going to create an angle, and this angle here is definitely going to be 20 degrees as well. There's a rule, a circle theorem rule that says that. So this angle here has to be 20 degrees, and all, when I say for the reason here, you're going to say angles in the same segment right, are equal. That's all we need to say here in order to get this market. All right, so that's part one. Now part two, we want to work out JOK. Now where is JOK? So again, you have to go to the diagram and make sure you understand where this is. Now JOK, we're going to make use of the fact that OJ is a radius and OK is also a radius. So that means that this angle across here is 50 degrees because you're dealing with an isosceles triangle. So JOK is equal to 180 minus 50 plus 50. Okay, so that's going to give us 80 degrees. So that angle JOK there is going to be 80 degrees based on the fact that JOK is an isosceles triangle. So when they ask you for the reason, you're going to say that. You're going to say that OJ is equal to OK, right? And that's the radius of the circle. So you need to tell them it's an isosceles triangle. That's the reasoning that we're using there. So that's part two. The next one we want JHK. So if you want JHK, you have to look at the diagram carefully and make sure you know what is JHK. So JHK is actually this angle here. That's what you want, right? JHK. Okay. Anybody know how we're working out JHK? All right, I see people getting 60 degrees, 110, JHK. If I just look at the diagram, JHK should right? I see all kind of answers for JHK here, right? Now, any real exam, right? If you have any issues with any question like this, right? You can just ignore this question and just move on. If you know you can't do circle theorems, just go on. Okay. Some people say how to do with tangent. Yeah, that's the part. That's what I'm gonna work out. I'm gonna work out the third part, right? I'm gonna work out the third part. All right. Okay, so here's what we're gonna do, right? What we could do in this question here. So first of all, I actually know that this angle here is a 90-degree angle because you see this line here, this line here, that's your diameter of that circle. If we use the diameter, the ends of the diameter of the circle to make an angle on the circumference, that's going to be 90. So you see this angle here, this is 90 degrees here. This small little angle here is 20 degrees. So technically, I can work out this angle here as well. So you see this angle here, that angle there is going to be 180 degrees minus 90 plus 20. Okay, so that's going to be 90 plus 20, that's 110, 9, 10, 11, yeah, 110. So 180 minus 110, you're going to get 70 degrees. So this little piece here is 70 degrees. Now, what I'm going to do here, I'm going to make use of the fact that H, J, K, and L, they are on the circumference of the circle, so they form a cyclic quadrilateral. So you see this whole angle here, this whole angle here, and this whole angle here, those are angles that are supplementary. So what we can say here is this, 180, right, minus the 20 plus the 50, right? So that's going to be 180 minus 70. So that's going to give us 110. Now that 110 here is really this whole thing here. So if I want to get this angle JHK, JHK is simply going to be 110 minus 70 degrees, right? So that's 110 minus 70. So you're going to get 40 degrees. Okay, so I think I saw some people put 40 degrees in there as their answer. Yeah, it is going to be 140. Okay, that's one way of working it. Let's see. Somebody said if you can use, yeah, somebody says if we can use the center. Let's see. Can we? Or is that going to help us too? Does it really help us? Yeah, you could have used that. Actually, yeah, it does, right? So some of you are saying that HKL, right? HKL is 20. That's let me see, HK, let me make sure I tell you this correct, eh? Right, not HKL, sorry, not HKL. You can use the fact that this angle, make sure I'm telling you this correct, eh? Yeah, you could use that actually. You can use JOK. JOK is 80 degrees. Yeah, and half of 80 is, yeah, that's an alternative way, guys. That's actually a faster way to do it. Yeah, that's a faster way to do it. Okay. All right. So well done for those of you who saw that. Yeah, you could use that. Right. I know one or two people were asking about vectors here. Right. So let's have a look at this question here. We have position vectors of points P and Q relative to an origin O. So we have OP, which is given by 4, 3. We have OQ, and that's given by 5, 0. And they are also telling us that in the diagram, we have PR, which is 3OP. So PR is 3OP, and QS is 3OQ. So in this case here, what's happening? So this diagram doesn't look like it's drawn to scale here, right? So let's see. PR is 3 times OP. So that means that this here is broken up into 3 equal parts. And the same thing applies to this here. This is broken up into 3 equal parts. Okay? So the length of PR is 3 times the length of OP. Okay? So the first thing we want the vector OS. Where is OS? So if OQ is equal to 5, 0, and you want to work out the vector OS, right? Now the vector OS, if we look at the diagram carefully here, vector OS is equal to 3 times OQ, right? The vector OS is 3 times OQ. So this is going to be 3 multiplied by 5, 0. So this is going to be 15, 0. Right? So let me make sure I'm saying that correctly. OS is... Sorry, no. That's not correct. All right, I read the letters wrong. All right. So OS is this full length here, right? OS is this full length here. But that full length there is actually 1, 2, 3, 4. It's actually 4 times, right, the vector OQ. So in this case here, it is going to be 4 multiplied by 5, 0. So that's going to give us 20, 0. Okay, so that's the vector OS here. The next thing we want the vector PQ. So PQ is from here to here, right? You want the vector PQ. So to get PQ, you're going to go from P to O, and then you're going to go from O to Q. So in this case here, the vector PO is the reverse direction of this vector here, which is going to be minus 4, minus 3. So anytime you want to reverse the direction of a vector, just multiply by minus 1. Plus the vector OQ. OQ in this case here is 5, 0. So when I add this here, minus 4 plus 5, you get positive 1. And minus 3 plus 0, we get minus 3. So this here represents the vector PQ. Okay, for 2 marks, that's what it is. Now the third part here, they want the vector RS. So this here represents your vector RS. So how do we get RS? So the vector RS is simply going to be equal to, so you can go from R to O, and then from O to S. So what is the vector RO? Now RO is this vector here. So we're going in the opposite direction. Now the thing is, 1, 2, 3, 4. So RO So let's work out RO first actually, yes. Now RO is simply going to be 4 times the negative value of OP. So in this case here, OP is 43. So it's going to be -4, -3. Sorry. You know what? I'm just going to write it separately first. So I do like to do it in one shot, right? Let's work out OR first, right? OR is simply going to be 4 times OP. So this is going to be 4 multiplied by OP, which is 43. So that's 4 4s are 16. So that's 16 12, right? So that's the vector OR. So if I want RO, it is going to be in the opposite direction. So that's -16 -12. And then you're going to add that to the vector OS, which is 20 and 0. So in this case here, -16 plus 20 is going to give us 4. And -12 plus 0, we get -12. Right? So that's the vector RS here. Right? So I hope that kind of making sense. So the next part here, they said state 2 geometric relationships between PQ and RS. Now look at this carefully here. Based on what we've drawn, we've actually drawn 2 vectors here. One is PQ and one is RS, right? So we have these 2 vectors here. Now whenever they ask you for geometrical relationships, what they could mean that they're parallel. So whenever 2 vectors are parallel, you can write one vector in terms of the other vector by writing it as A is equal to a constant times the other vector. Now, if you find a relationship between PQ, like look at this, PQ, if you just look at the vectors here, PQ and RS, so PQ is actually equal to, or better yet, let me do it this way instead, RS, right, is equal to some constant multiplied by PQ, okay? So let's see what that constant is. So RS is 4 -12 is equal to some constant, some key, multiplied by PQ, which is 1 - 3. Now, if you just look at the numbers there, the only way this is going to be equal here is if this K here is actually equal to 4. Okay? So what we are saying is that the vector RS is equal to 4 times the vector PQ. Whenever you are able to write something like that, you can see that the vectors are parallel. Okay? So the 2 relationships they're talking about here is that RS and PQ are parallel. Right? They are parallel. The second thing we can say here is that we can speak about the length. So we can say that RS is equal to 4 times the length. So you can write this in terms of lengths. So you can write it like this. PQ. Right? So that's the 2 geometric relationships we're talking about here. Okay? Right? Some people asking about transformation. Well, I did transformation in the earlier session, right? I did transformations in the earlier session. So some of you all missed out by not being here earlier. So I had a session that started today at around 11 o'clock, right? So in this case here, you all can go back to that recording if you want, right? To check that out. Right? Somebody wants a next question on this vectors here. Try our next one here, right? Our next vector here that has column vectors. These are all CXC questions, by the way. They're all CXC questions. All right, so here's what's happening here. We have position vectors OA, OB, and OC. Okay. Now, what I normally do sometimes, I'll do a little sketch, especially when it comes to these vectors. So in this case here, I have, I feel something blocking you here. Yeah, so we have some lights. So we have a vector. So this is O, this is our center here. We have OA. So 2 minus 2 is somewhere down here. Right, so this is A. We have OB, which is 6, 1. So OB is 6, 1. Okay, so that's going to be somewhere up here. Right, that's B. And OC is 10, 4. So OC is somewhere up here. Right, or C is somewhere up here. So first of all, we have these points here. And right, so you have OA, that's a vector. We have OB, that's an X vector. And we also have OC. Okay, so I'm just putting approximate locations for these vectors here. Now, what we want to work out what is the vector AB. So to work out the vector AB, that's this vector here. So you're trying to get from A to B. How do we do that? So the vector AB is equal to AO. So you're looking at the path taken to get from one location to the next. So AO plus OB. So in this case here, AO. What's the vector AO? Now OA is 2 minus 2. So if you want AO, you're going in the opposite direction. So that's minus 2, 2. And you're going to add that to the vector OB, which is 6, 1. So minus 2 plus 6, you're going to get 4. And 2 plus 1, we're going to get 3. So that's our vector AB here. Next one here for part 2, we want to work out the vector AC. So AC is all of this here, right? AC is from here to here, right? So how do we get AC? So if I want to get a vector AC, so AC is simply going to be equal to AO plus OC. So in this case here, AO is the same minus 2 and 2. And you're going to add that to the vector OC, which is going to be 10 and 4. So minus 2 plus 10 will give us 8. And 4 plus 2 is going to give us 6. Okay? So I have worked out AB and I've worked out AC. Easy 3 marks. The next part here now, they said, hence, determine whether A, B, C are collinear and give a reason for your answer. Now, this is a common question that CSEC brings in the exam, and lots of students, they get it wrong. And they get it wrong because they're not sure how to actually answer the question. That's the problem. They're not sure how to actually answer the question. So in this case here, what we're going to do, there are 2 things we need to see. So first of all, we need to find if there's a relationship between the 2 vectors, AB and AC. That's the first thing we need to do. So if we look at this carefully here, AC, let's write that as K times AB, right? So we're trying to find if there's a relationship between the 2 vectors. So the vector AC is 8, 6, and the vector AB is 4, 3. So what's the relationship there? You will notice, right, that this K here has to be equal to 2. So what we're going to say, AC. Now this is how you're going to write your answer. AC is equal to 2 times the vector AB. Right, that's the first thing. You need to find if there's a relationship between both of them. And then we're going to make a statement that says, since, this is exactly what CSEC wants, since AC is a scalar multiple, right, of AB, right, they are parallel, right? So they are parallel. I'll tell you exactly how CSEC marks this question. So the first thing they will look for is to see if you have the relationship between the 2 vectors. So this is 1 mark for this. Then you're going to get a second mark for saying this here, that the 1 vector is a scalar multiple, so they are parallel. Again, that's the second mark here. Now the third mark that you're getting, because this is normally a 3 mark question, watch carefully here. Then you're going to say, so you're dealing with 2 vectors, AC and AB. You're going to say since the vectors, right, AC and AB, right, have the point A in common. They have a common letter, right? In this case here, they have the point A in common, right? That tells us that A, B, and C are collinear. So if you've never seen how this question is marked, this is how they mark this question here. It's normally 3 marks in the exam, and they give us 1 for coming up with a relationship. The second mark is for saying that they are parallel, and the third mark is for saying or identifying what the common point is. That's what the third mark is for. So I've seen a lot of students get this wrong, right? I've seen a lot of students get this wrong, but you have to be able to write this out properly in order to get a mark, right? Right? I'm going to do one more, right? I'm just going to do one more of a particular type of question here for you guys, all right? The 2 examples I did there would have been column vectors, but you could get something like this. So the diagram below, not drawn to scale, it shows a parallelogram, and they give us some information here. So first of all, let's see what they give me here. So we have OMLK, that's a parallelogram. So whenever they tell me anything about a parallelogram, my suggestion to you here is to put in certain things one time. It means that this vector here has to be V. It also means that this vector here is U. So once you see the word parallelogram, that is what you should do. Write in those vectors one time. Now the next thing here, they told us that the point S is on KM such that, so they're giving us a little relationship here now. So they said that MS is 2 times SK. MS is 2 times SK. Now from here to here, that's the length SK. Now MS is twice that length here. So that means that the whole line KM could be divided into 3 equal parts. That's basically what they're saying here. Now the first part of the question, they want MK in terms of U and V. So the vector MK, right, the vector MK here is simply going to be MO, right? Look at the direction of the movement plus OK. So in this case here, MO, you want to go this direction here. So that's going to be minus U plus V. So that's MK. That's why they're only giving you 1 mark. It's too easy. The next thing they want you to work out is SL. Now the vector SL is this vector here, right? That's this vector here. How am I going to do that? Well, first of all, if I want to go from S to L, I can go from S to K. So you can go from S to K, and then from K to L. Okay, that's a part that you could take in order to create that vector. S to K, K to L. Now, what is the vector SK? According to the diagram there, SK is actually going to be 1 part out of the 3, because that line MK could be divided into 3 equal parts. So SK is actually 1/3 of the vector MK, right, plus KL. So now I'm going to substitute my vectors inside it. So this is going to be 1/3. Now the vector MK, we just worked that out. We got minus U plus V plus the vector KL, which is U. So in this case here, this is minus 1/3 U plus 1/3 V plus U. So when I work this out here, if I take U minus 1/3, this will be 2/3 U plus 1/3 V. Now these kinds of questions here, people struggle with these questions, right? People struggle with these kinds of questions. right? Yeah, don't worry, I'm gonna move away from vectors just now, right? Because I've done I've done a lot of questions on vectors, so I will move away from this in a sec, right? This is the last vectors I'm doing. I've done a few already in some previous lives. So this is SL here, right? So I worked out SL. The next thing we want the vector OS. So the vector OS here is this line here, right? That's the vector OS. So how do we get OS? So the vector OS, right? If you look at the diagram carefully, we can go from O to S. I can find a shorter route to get it. All right. So I can go from O to key, right? And then from key to S. So plus key S. That's one route I can take to get there. Now the vector OK is equal to V plus the vector KS. Now KS is simply going to be, let's see if I'm making sense. Should I go that route? Right? Yes, make sure I'm doing this correct. One sec. All these letters, after a while, they look the same, right? Hold on. SL is S key. One third of M key. Okay, yeah, that's looking okay. I thought I made an error there. Okay, let's go back to OS. So OS is equal to OK plus KS. Right? Now, OK is V plus KS. Now, KS, we're going in the opposite direction, right? So it's the opposite of this vector here. So in this case, that is going to be minus 1/3 by minus U plus V. You see this vector here? This here. This is actually SK here. That's the vector SK. But if I want to go in the opposite direction, I just need to put a minus sign in front of it. That's what I'm doing here. So in this case here, I'm going to get V, right? Plus 1/3 U, okay, minus 1/3 V. That's what I'm getting here. So this is going to be 1/3 U, right? V minus 1/3 will give me 2/3. So this is going to be 2/3 V here. Right? I hope that kind of making sense, eh? I hope. Yeah. People say they're fasting and praying tomorrow. Right? I just double checking to make sure this is correct what I have here so far, right? Just give me one sec. Let me see. MK. Right? I've been working for like non-stop for a good bit of hours for today, right? So give me one sec. Make sure I copy this question across correctly. Right? Yeah, so that's actually that's it, right? That's it. That's all I wanted here. Okay. All right, so let me move away from something that is a little depressing for some of you all. I know some of you all don't like vectors or matrices, and you really shouldn't do it if you are not comfortable with it, right? So let's move across to something that may be a little better. I hope. All right, so let's move across to a little measurement type question. Okay. Right, so I feel some of you all might be able to get some marks in these kinds of things, right? Right, somebody put asking about bearings. Some of you all missed the first session. The first session, I did some bearings questions here. All right, so we have a figure here, not drawn to scale. It shows a circle with center O. The radius of the circle is 21 cm, and HOK is 40 degrees. So the first thing we want to calculate, what's the area of the minor sector? So first of all, the minor sector they're talking about here is this here. When you break up a circle, you can break it up into a minor or major segment, right? Sorry, hold on. Let me say this over. If I have a circle, right? If I have a circle here, and I were to have a sector like this, right? This here is what we call the minor sector, right? And this here is your major sector. Okay. Similarly, if I have a circle and I were to draw a line here, and this line here is a chord, it'll divide the circle into two unequal parts. So this smaller part here is called the minor segment. That's the name given to this. It's called the minor segment. And this on top here is called the major segment. Right? That's what this is called. All right, so let's go back here. So the first thing we want to do, we want to work out the area of the minor sector, HOK. So first of all, that formula is actually given to you guys in the exam. So area of minor sector right? And this formula, like I said, is given. It is actually theta on 360 multiplied by pi r squared, right? That's the formula to find the area for minor sector. So the angle in this case here is 40 over 360 multiplied by pi. Now use pi as whatever they give you pi as, okay? If they say use it as 22 over 7, that's what you're going to use. Multiplied by the radius squared. So that's going to be 21 squared. Now usually when they give us to use pi as 22 over 7, the answer may work out flush. Not sure as yet, but let's see. So that's 40 over 360 multiplied by pi, which is 22 over 7, multiplied by 21 squared, right? And this works out to be 14 cm squared. So that's the area of the minor sector in this case here, right? That's the area of the minor sector, right? Yeah, if you get a question like this, you jump in for joy for sure with this particular question, right? So that's 2 marks. The next thing we want to do, we want to work out the area of the triangle HOK. So the area of triangle. All right, so the area of a triangle here, what we're going to use, we're going to use the fact that there's a formula that says a half by A by B by sine of C. Okay, so there's a formula. So I know you all are accustomed to a half base by height over 2, but there is another formula where we tend to use when we're dealing with sectors. So it's going to be a half. Now this length here, OH, is also 21. So it's going to be a half by 21 by 21 multiplied by sine of 40 degrees. So in this case here, it is going to be 0.5 by 21 by an x 21 by sine 40. And I'm going to get, 1 second, 0.5 multiplied by, right? I need to double check that area that I work out just now there. Something not looking right with the area of the sector. Check that out. Yeah, yeah, that's what I'm saying. I feel like I entered something or I wrote out something wrong on the calculator there, right? So this not looking right because if I got 141.1, this number has to be bigger than that, right? I feel I pressed something wrong or I wrote the wrong thing. 40 over 360 multiplied by 22 over 7 multiplied by 21 squared. Yeah, 154. Yeah, right? I probably pressed something wrong. So that's 154. The next thing they want the area of the shaded segment. Well, if you want to get the area of the segment, so the area of the segment is simply going to be 154. That's the area of the sector minus the area of the triangle. So that's 154 minus 141.7, and you're going to get 12.3, right? And that's going to be cm squared. Okay. So this is a nice question if you get something like this involving a sector. I'm looking at, I've done so many questions online. A lot of these questions, they're starting to look like, okay, I've done this before. I've done all of these questions before. All right. Let's see a nice one here again. All right. So this one here, we have water is poured into a cylindrical bucket with a base area of 300 cm cube. Right. Now this is not looking right there. This ought to be cm squared. Can't be cm cube because it's talking about area here. If 4.8 liters of water is poured into the bucket, what is the height of the water in the bucket? So here's what's happening here. So you have a base, right? You have a base here. And try to draw this here properly. Right? So we have a cylinder. That's basically what we have here. Right? You have a cylinder. And the base area, so this base area here is 300 cm squared. Okay. Now, what you're doing here, you're pouring 4.8 liters into this thing here. So you're pouring, so you're coming here now and you're pouring 4.8 liters into that container. Now, obviously, when you pour that into the container, the water is going to fill up to a particular depth, right? So this here is going to be that depth there. So in this case here, we don't know what the depth is. So let's call it H, okay? Now, first of all, that 4.8 liters, let's convert that into cm cube. Now, you guys need to know that one liter is actually equal to 1000 cm cube. So 1 liter is 1000 cm cube. So if I have 4.8, all I need to do is to take 4.8 and multiply by 1000 in order to convert that into cm cube. So this is going to be 4800, right? 1, 2, 3 cm cube. So that's the volume of water that we're pouring into this container here. Now, the volume of a cylinder is really pi r squared h, okay? But if I want to work out h is simply going to be equal to the volume divided by pi r squared. So the volume of water we add into the cylinder is 4800 divided by pi r squared. Now pi r squared is actually this, that's the base area. So you're going to divide that by 300 here, right? So that's simply going to be 48 divided by, well, yeah. So this is going to be 16 here, cm. Okay? So that's the depth of the water inside that container there. That's the depth of the water in that container. Okay? Right? Not all formulas are on your formula sheet, guys. Not all the formulas are there for the exam. So some formulas, you're going to have to remember them. right? Let's see what else we have here. We have a next part to the same question, right? Which is the same. All right, the diagram not drawn to scale. You have a cuboid. It has a length of 13. One of the width is 4 and the height is h. State in terms of each the area of the shaded face. Okay, so this is like a real baby question here, right? So the area of the shaded face is simply going to be 4 multiplied by h, which is 4h. That's it, right? That's why it's only 1 mark. Now they want expressed in terms of h, the volume of the cuboid. Again, this is also easy marks here. So the volume of the cuboid is equal to the cross-sectional area multiplied by the length of the cuboid. So the cross-sectional area is 4h, and you're multiplying by the length. The length in this case here is 13. So you're going to say 13 by 4, and you're going to get 52. So this here is going to be 52h. That's your volume of this cuboid. And the third part, if the volume of the cuboid is 286, find h. So for this third part here, all we need to do, so your volume is 286. So we're going to put 52h is equal to 286. So therefore h is 286 all over 52. So therefore h is equal to 286 divided by 52. And you're going to get 5.5. All right. So this one is pretty easy question. Okay. Right. Let's try next one here. All right, so Fresh Farms Dairy sells milk in cartons in the shape of a cuboid with internal dimension 6 by 4 by 10. I want to calculate the volume. So you want to calculate the volume in cm cube of the milk in each cartoon. So volume, all right, once you have to find the volume of a cuboid, it's simply going to be length by width by height or length by breadth by height. So 10 by 4 by 6, anyhow you want to take it, right? Some students will tell you, well, the length, let's take it as 6, the width is 4, and the height is 10. It really doesn't matter. So 6 by 4 is 24, 24 by 10, you get 240. So this is going to be cm cube. So that's the volume of milk in this cuboid here. That's the answer for part 1. A recipe for ice cream requires 3 liters of milk. How many cartons of milk should be bought to make this ice cream? Now, you want to make ice cream here, but you require 3 liters. So remember, I just told you that 1 liter is 1000 cm cube. So if you have 3 liters, this layer will be 3000 cm cube. That's the volume of milk that you need to make this ice cream here. Now, you want to know how many cartons of milk. So number of cartons of milk is simply going to be, so we have to take 3000. All right, and we have to divide that by 240 here. So in this case here, we're going to get 3000 divided by 240, and you're going to get 12.5. Right? Now the thing is, you can't buy half a pack of milk. So in this case here, the number of cartons here, we're going to approximate that, and we're going to say 13. Okay? So when you get questions like these here, you have to make certain assumptions. Right? How come they're giving us 3 marks to that? That's not looking right. Okay. Now they said 1 carton of milk is poured into a cylindrical cup. So now we're taking all of this here and you're pouring it into a cylindrical cup, just like we did just now. So you have this here, you have a cup, and you want to pour the milk into this cup here. So the amount of milk that we're going to pour into the cup is 240, because that's the volume of one cartoon of this milk here. So 240 is being poured into this. They're telling us that the internal diameter, right? The internal diameter is going to be, right? The internal diameter is going to be 5 cm. So this here is going to be 5 cm. That's the internal diameter. They want to know, just like the previous question, so you're pouring the milk inside here, and what's going to happen is that obviously the milk is going to rise to a certain depth here. Okay, so all we need to do to work this out, we're going to say the volume of a cylinder is pi r squared h. So if you want to work out the depth is simply going to be v divided by pi r squared. Now the volume of milk that you're adding to this cup here is 240. You're going to divide that now by pi. Now in the question, they told us what to take pi as. They told us to take pi as 3.14. So this here is going to be 3.14 multiplied by the radius squared. Now, the thing is, they told you that this here is your diameter. So therefore, the radius is going to be 5/2, which is 2.5 cm. So look out for little things like this in the exam. When they tell you diameter or they tell you radius, because they said internal diameter. Some students might read this and they might just say that's a radius. So please be careful, right? So let's see. So in this case here, this will be 2.5 squared, right? So let's work this out here. So this will be 240 divided by, open brackets, 3.14 multiplied by 2.5 squared. And we're going to get about 12.2 cm as the depth of the milk in that container, right? About 12.2 cm. Right, somebody's asking about a grade 1 or grade 2. Yeah, what? If you all do excellent in the multiple choice and you have a good SBA mark, you just need to make more, let's say about 60 out of the 100. Or 60 out of the 100, and that should be fine. There are cases where they don't give you what, yes, I've seen instances where CXC gave us, they did not give us a value for pi. And if they don't give you a value for pi, you go ahead and choose either 3.14 or 22/7, right? Any one of them there you can work with, okay? Right, I'm just looking at some of these questions here, and a lot of them I've done them before, so it doesn't make sense doing them over again. Right, let me just do a simple statistics question here with you guys. All right, a class of 50 students counted the number of books in their bags on a certain day. The number of books in each bag is shown below. So we have number of books found in the bags of students in a school here. We want to copy and complete this table here using the data that we have. Okay, So first of all, they fill it out for number of books being 1 and number of books being 2. So what we're going to do here, let's look at number of books here being 3. So first of all, we have 1, 2, 3, 4, 5. Okay, so in this case here we go 1, 2, 3, 4, 5. So this frequency here is going to be 5. Then let's look at the 4 here now. So we go across, we have 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, 6. So this is going to be 6. Then we go to 5. So we have 1, 2, 3, 4, 5, 6, 7. So you have 7 here. So we go 1, 2, 3, 4, 5, 6, 7. So this is 7. Then we go into 6 now. So we have 1, 2, 3, 4. Right? So I'm seeing 4 here. So 1, 2, 3, 4. So this is 4. And then we have 7 now. We have 1, 2, 3. Right? So I'm seeing 1, 2, 3 here. So this is 3. Now, if ever you are given a question like this in the exam, my suggestion to you is to add up the frequencies and make sure that you get 30. That's just a double check to make sure that you didn't miss anything. So 3 and 2, 5 and 5, 10. 10 and 6 is 16. And 7, that is 23. 26. Yeah, that's 30. Okay, so we're correct here. So always double check, add up your frequencies to make sure that they do add up, right? So that's 30, right? So that's the first part, copy and complete the table, but they want us to work out the fx column here. So you're taking the frequency and multiplying by the variable. So 3 by 2 is 6, 5 by 3 here, this will be 15, 6 4s are 24, 7 5s are 35, 6 4s are 24, and 7 3s are 21. All right, so that's what we have here. So that's part A. We just have to complete the table. In part B, we have to state the modal number of books of the sample of students. Let me ask a question here. What's the answer for this here? What's the answer for the modal number of books that we have here? Right, we were saying 5. So let's check. Now, when you have to do a question like this here, we're looking for the highest frequency. The highest frequency is 7. But the answer is not 7 though. You're looking at the variable in question here, which is number of books in the students' bags. So the mode is going to be, sorry, I'll circle around it. The mode is going to be 5 in this case here, right? 5. Right, the line's kind of tiny here. So the mode is actually going to be 5 because that corresponds to a frequency of 7. Now, using table A or otherwise, calculate the total number of books. Okay, calculate the total number of books. Now, when they ask you for the total number of books here, this is what they're asking us for. They're asking us for the sum of this column here. Because how you interpret in this table here, we have two students who have 1 book in their bag. The next one, we have 3 students who have 2 books in their bag. So all I need to do is to add up all of this here. So that's going to be 8 plus 15 plus 24 plus 35 plus 24 plus 21. And we're going to get 127 books here, right? That's 127. 6 by 4, 6 by, okay. So this here is going to be 127. The next part, they want you to calculate the mean. So for those of you who can't remember, there's a formula for mean, and that is given by sigma xf all over sigma f. So sigma xf in this case here is going to be 127 and you're going to divide that by sigma f, which is 30. So 127 divided by 30, and we're going to get about 4.2 books. Okay, now you don't round it up, leave it as this to one decimal place, that's fine. And the last part, part D, determine the probability that a student chosen at random has less than 4 books in his bag. So the probability that the student has less than 4 books in his bag. So if he has less than 4 books, right, it means you can have either 3 books, 2 books, or 1 book. Okay, so what's the probability that a student chosen at random has less than 4 books? How many students are we looking at there? So 2 students had 1 book, 3 students had 2 books, and 5 students had 3 books. So you have to add up the total number of students who had 1, 2, and 3. And then we're going to divide that now by the total number of students, which is going to be 30. So this is going to be 5 and 5, 10. So that's 10 over 30. So that probability here is going to be 1/2. Okay, that's the probability there, 1/2. Right, now this here, this is how we calculate mean when we have data, right? When we have raw data like this. However, you could be given group data and you could be asked to find certain things as well. So let me show you an example like that. So let's say we had some lights. Okay, so the heights of a sample of seedlings were measured to the nearest centimeter and then arranged in class intervals. So if you notice here, we have class intervals. We have 3 to 7, we have 8 to 12, and so forth. The question is asking, how many seedlings do we have? Right? How many seedlings do we have? So if we look at the frequency, we're going to use this in order to work out the number of seedlings. So we just need to add up the frequencies to get that. So sigma f, that's the sum of that column there, right? So that's going to be 15 plus 16 plus 22 plus 18 plus 14. Oh, they're busy typing on the calculator off. So that's 15 plus 16 plus 22 plus 18 plus 14. Okay, so I'm getting a total of 85 plants here. Okay, you all can double check that for me, but I'm getting 85 plants here. Right? Right, so don't keep spreading that, guys. Right, to get a grade 1 in maths is not 90%. I can guarantee you that is not true. 85%, I can guarantee you that's not true. Right, to get a grade 1 in maths. Okay. So for the class interval 8 to 12. So we have a class interval here 8 to 12. Okay, and they want a few things here. They want a lower class limit. Could you all put in the chat for me, what is the lower class limit for that interval? What is the lower class limit for that interval? Right? Now, the real question is, where did you all see that? Right? So I can tell you for a fact, CXC has never published anything like that, telling us what a grade 1 is, what a grade 2 is, or what a grade 3 is. I can only tell you based on the performance of my students, I can give you an idea of what it is. A grade 1, based on the performance of my students, it's approximately a 75, right? And I feel it can go as low as a 73, right? But 90, I don't know where you all get this 95%. That's not true, right? So those of you who think that's what you need to get a grade 1, that is definitely 100% not true. Okay. So more like about 75, 73, somewhere in that vicinity, I believe. Okay. So what about this question here? What is the lower class limit for that interval 8 to 15? What do you all think is the answer there? Right, a grade 2, like I said, this is based on the performance of some of my students. So a grade 2 is somewhere in the vicinity of 65 and above, around there. And a grade 3, right, could be as low as a 53 or 52, somewhere there, right? But that's where we expect a grade 3 to be. Okay, so they want the lower class limit. Some people are saying the answer is 7.5, some people saying 8. So which one is it? So first of all, they said the lower class limit. Now be careful with this if you see this in the exam. The answer is actually 8, not 7.5, right? So when you have, so this here, this number here is your lower class limit, right? That's what this is called, your lower class limit. This here is called the upper class limit. Okay. Now, what they can also ask you as well, because some of you are mixing up your terms here. Now, if they want you to say what the lower class boundary is, so the lower class boundary your lower class boundary here, in this case here, is actually going to be 7.5, right? So some of you always saying 7.5. That is called a lower class boundary. That's what it's called. For the upper end here now, right? If I were to ask you for the upper class boundary, so the upper class boundary in this case here is actually going to be, so the upper class boundary is 15.5. Okay, so when they ask us for this part here, what's the upper class boundary? This is going to be 15.5, right? Oh, sorry, 8 to 15 or 8 to 12? Sorry, it's 8 to 12. My bad. I wrote the wrong thing here, right? So it's 8 fixes. Right, 8 to 12, right? So this here is going to be 12.5, right? That's what this is, 12.5. Okay. And what about this part? This third part here, students also get wrong. Yeah. Yeah, that 15 was a typo, don't worry, right? It's 12. My question to you is, what is the class width? This is something people get wrong, right? What's the class width in this case here? Yeah, try your best to answer the questions that you know how to work first, right? Don't study the hard ones as yet. Go to the hard ones after, right? What's the class width? I want a value for the class width, right? This is a common thing that students get wrong in the exam, right? It's a common thing that students get wrong in the exam. What is the class width? Yeah, circle theorems. Yeah, almost every year we get a question on circle theorems, right? That January exam paper was a little different, but almost every year we do get circle theorems. Yeah, I'm gonna do a quick run through of things you need to know for your formulas here for statistics, right? So some people saying 4.5, some people saying 5, some people saying 4. So here's what you need to know. Your class width, right, is simply equal to the upper class boundary. Now pay attention to this, minus the lower class boundary. What some students do, they just look at the interval here and they just subtract these two numbers. So people are going to tell you 12 minus 8, but no, it is going to be 12.5 using class boundaries to work this out. And the lower class boundary in this case here is 7.5. So 12.5 minus 7.5 is going to give us 5 as our class width. So be careful with those things, right? Be careful. right? So here it said, don't go in your exam and write your exam in pencil, right? Don't write your exam in pencil. Graphs, draw your graphs in pencil if you need to, but your actual exam, right? Your actual exam, just focus on using a pen, right? Use a pen, right? Yeah, I did a construction earlier in class, right? Okay, let me just tell you one or two things you need to know when it comes to certain diagrams. There are a few formulas that we have to be aware of. So first of all, if I want to calculate mean and I have raw data, it is simply sigma x over n. So if I had a string of numbers, right, or a string of scores, I just add them up and divide by how many I have. So that's the most basic formula for mean. I can also calculate mean from group data, and that table looks like this: sigma xf over sigma f. And when I say group data, the data is in a table, right? It's in a table. So for example, if I had something like this, let's say we had I'm just going to call some variable here, right? Let's say we had some variable and we had a frequency here, and this is 2, 3, 4, 5. So let's say students passing subjects in a class or something, so right, and I have some values here, right? 6, 2, and maybe 1, right? So these, let's say this represents the number of subjects passed by students or something like that. I can calculate the mean by simply creating a new column here called the XF column. So I'll have to take each one of these variables and multiply them. So this is 1 by 2 is 2, 4 2s are 8, 6 3s are 18, 4 2s are 8, 5 here. So what I could do, I can work out my sigma f, and here I can work out my sigma xf. So I'll use this formula here if I want to calculate mean. Now if, however, instead of having a table like this, I had a table where we had a grouping instead. So we had an interval, let's say 1 to 5, then 6 to 10, then 11 to 15, then we had 16 to 20, 21 to 25. Okay, so let's say we were looking at scores of students in an exam, and let's say we had like 2, 6, 9, 12, and 8. So let's say these are scores, right? These are scores of students here. If you want to calculate the mean from a table like this, what you're going to have to do, you're going to have to create a midpoint. So we need to calculate the midpoint of your class intervals. So to get the midpoint, all you need to do is to add up the two numbers and divide by 2. So 5 and 1 is 6. 6 divided by 2 is going to be 3. The next one here, 10 and 6 is 16 divided by 2. That's 8. The next one here is going to be 13. Right? Yeah. And this one here is going to be 18. And then this one here is going to be 23. So that's my midpoint. To get midpoint, we just take the two limits, add them up and divide by 2. And then what you're going to do, you're going to have to create a new column here called XF. So 3 2s are 6, 8 6s are 48. All right. And we keep going like that. So just like with the other table, you're going to have to work out what is sigma xf. Add up everything in this column here. You're going to have to add up your frequency, add up everything in this column here, but we're still using the same formula in order to calculate your mean. Okay? Now there are a few graphs, right? There are a few graphs that you guys have to know. There are a few graphs that you all have to know in the exam. Okay? So in this case here, let's just review something here. If I want to draw cumulative frequency, if I want to draw a cumulative frequency curve, okay, what I'm going to plot, and this is something you need to understand. When you're plotting a cumulative frequency curve, you actually plot cumulative frequency, and you're plotting that against whatever variable it is. Okay? Now, make sure that this variable that we're using here, each point that we plot in here, we use upper class boundary. So when you're plotting your cumulative frequency curves, we use upper class boundary, right? That's what we use, upper class boundary. Keep that in mind. Now, when you draw a cumulative frequency curve, the curve generally will look like this. All right, that's what the curve looks like. Any multiple choice, they can ask you what is the name of that shape. It is called an ogive, right? That's how you work out, or that's the name of the shape. It's an architectural shape apparently. So one of the things we have to understand is that your maximum cumulative frequency, that's this value here, right? Yeah, let's just cut that off here. Right, so let's call that n here. That's your maximum value. So when you want to estimate, now remember this is an estimate that we're working out here. You could be asked in the exam to estimate what is the median. So if you want to estimate the median, all I need to do is to find a half n. Sometimes you might see it written as a half n plus 1. Because we're estimating, it's really not going to affect anything here. It's going to be approximately that either way. So if I want to get a median, you're going to find half of n, and then we're going to come down here. And when you reach here now, you're going to read off this here. This here is called Q2, and that's called your median. Right? That's what you call it. This is your median. So this is Q2. If I want to work out the lower quartile, all I need to do is to find a quarter of n, or sometimes you'll see a quarter n plus 1. But then we're going to come down here now, and we're just going to read this here. So this here is Q1. If you want to get the upper quartile, the upper quartile is actually 3/4 of n, or 3/4 n plus 1. And what you're going to do, you're going to read here, right? That's what you're going to read off here. So that's your, so Q1 is the lower quartile. So Q1 is the lower quartile, Q3 is the upper quartile. All right, so be aware of that, right? Be aware of that. Right? All right, so few things we need to know here, right? A few things we need to know. There are a few formulas that you need to be aware of. So the interquartile range, right? Write it as shorthand here, is going to be Q3 minus Q1. That's the formula for the interquartile range. Also, we could be asked to calculate the semi-interquartile range. And in this case here, it is going to be a half of Q3 minus Q1. So these are some formulas we need to be aware of when it comes to the cumulative frequency curve. Always remember, you are plotting upper class boundary. There are some students who go in the exam and they plot midpoint. It is not midpoint, it is upper class boundary. All right. In this case here, what else do we need to know? Oh, just remember that your cumulative frequency curve only gives you less than information. Okay, that's a key point here you need to remember. So you have to be able to sketch or to draw a cumulative frequency curve. We can also be asked to draw a frequency polygon. Now, when you have to plot a frequency polygon, what do we plot? We plot midpoint, right, against frequency. That's what you plot when you're plotting a frequency polygon. Now, in this case here, on your y-axis, you're going to have frequency. And on the x-axis here, it's going to be whatever variable we're talking about, but it's midpoint you're plotting. So when you plot the points, you might get something like this. So this might be midpoint against some frequency, midpoint against the next frequency here, midpoint against frequency, midpoint against frequency, and we're back to this point here. So when you're drawing a frequency polygon, what you do, you use your ruler to draw straight lines. So you're going to draw this to this, right? We're going to draw this to this, right? We're going to draw this to this. Now, what needs to happen though with a frequency polygon, and a lot of students, they leave this out here. The fact that it's a polygon means that you have to close the shape. So what you're going to do, you're going to have to bring this down here to here, and you're going to have to bring this down to here. What we're going to do, we're going to actually create a fake interval above what they gave us, and you're going to create a fake interval below what they gave us. And the only reason we're doing that is to be able to close the frequency polygon, right? That's all. That's the only reason why we're doing that. Okay. Somebody asked when last frequency polygon came. Honestly, it's been a while. I have not seen a frequency polygon in an extremely long while. Okay. So you need to know cumulative frequency curve. You need to know frequency polygon. We also need to know histogram and bar graph. Let me start with the easy one first. So bar graphs. So we use a bar graph for discrete data in statistics, right? Discrete data. Now, what do we mean by discrete data? So in statistics, whenever we use the word discrete data, we are talking about data that can only have specific values. So if we were to look at, let's say, cars parked in a parking lot, the cars could either be Toyota or Nissan or BMW, or these are types of cars. That's discrete data, okay? We use a bar graph when we're looking at discrete data. So for example, if you all are playing football and we're looking at the number of goals that you score in football, and I would have plotted a bar graph, it might look something like this. So you have frequency here, and let's say on the x-axis here, we have number of goals. So this could be number of goals scored, right? All right, so let's say that's number of goals. So let's say we have 0, right? Let's say we have 1, right? Let's say we have 2, right? So let's say we have intercall taking place here, right? And all right, so let's say we had a scenario like this. So using a bar graph, first of all, like I said, for discrete data that can only take on specific values. One of the things you notice with a bar graph is that the bars are not touching each other. There's a little space between the bars. That's a common feature of a bar graph, right? That's a common feature of a bar graph, all right? Now, bar graph is different from what we call a histogram, okay? Recently, they brought a bar graph question. Histogram, honestly, they haven't brought a histogram in a while, so this is a good contender, right? A histogram. Now, we use a histogram here for continuous data. Now, when we say continuous data, let's say all of you all are in this live right now. If I were to measure your heights, height is considered an a continuous type of data. If I were to measure the masses of all of you guys, that is considered a continuous data. Basically, the data can take on any value within a given range. That's what it means. All right. The data can take on a specific value in a given range. Okay. So for the histogram, you need to remember what you plot when you draw in a histogram. Because if this shows up tomorrow, you need to know what to do. So first of all, for histogram, it has to be applied to continuous data. And when you plot in a histogram, we're using your lower class boundary. So we're using lower class boundary and upper class boundary. Right? In order to plot this thing here. So first of all, when we draw a histogram, this is what happens here. So you'll draw a bar, right? This here will be a lower class boundary. This here will be an upper class boundary, right? And well, obviously this is your frequency. When you draw the next bar is going to touch and it's going to line up exactly with this here, okay? So you notice this is different from a bar graph. The bars are touching each other. So this is what we call a histogram, and it's used to represent continuous data. So you need to know what are you plotting, whether you're using midpoint, upper class boundary. So histogram requires these two things here, lower class boundary and your upper class boundary. Okay. The other kind of graph that we can also get in the exam is called a line graph. So a line graph is generally used to observe trends. So what we have in a line graph is frequency. So let's say we're looking at the months or the years, all right? And we're looking at, let's say, actually, no, wait, not frequency. Let's say we're looking at sales. right? We're looking at sales here, and we're looking at months. So we have Jan, we have Feb, right? We have March, right? So a line graph might look like this. What we do, we plot the points, right? We plot the points, but what you also do as well, you're going to use straight line segments in order to join the points. So we use a line graph in order to identify trends. So you can easily look at a line graph to know if your profit or your sales is increasing or decreasing, and allows you to make decisions quickly, right? That's the purpose of this. Okay. Yeah, generally somebody's asking frequency is always on the y-axis. Yep, it is. Yeah, for the most part. Right? So again, that's a line graph. The only other kind of diagram that we have to know for the exam is a pie chart, right? So we have a circle, right? And we can use a pie chart to represent information here, okay? So we have different angles to represent certain things. So this angle here is one thing, this angle here is another, this angle here is another. So you guys have to be able to calculate the angle of any given sector in a pie chart. So for example, if we had something like this, let's say we had some variables here, F, and let's say we had, let's say we're looking at the number of grade 1s in this class, number of grade 2s, number of grade 3s. Let's say we're looking at that. We're only looking at passes here. And let's say we had 8 grade 1s, and we had 12, right? And let's say we had 5 grade 3s here. If I want to work out the angle for, let's say, grade 1, then what I will do, I will say 8 divided by the total frequency, which is 12 plus 8 is 20, so that's 25. And then multiplying that by a full circle, which is 360 degrees. So that's going to be 8 divided by 25, multiplied by 360. And we're going to get about 115.2. Now I just make up these numbers here, right? But in the exam, CSEC might give you numbers that'll work out easily, right? Yeah, you have to use a protractor to draw these things, right? So again, these are just some of the graphs that we need to be familiar with, okay? Right? So I know some of you all probably starting to get saturated with all of this maths in your head, right? Let's see. Right, I'm just going to go back to this here. Right, let's deal with some fun stuff here that you all may or may not like, right? Some of you all may or may not like this at all. All right, so question 2 in your exam, right, is going to be based on algebra, right? Question 2 is going to be based on algebra, and this is typically one of the most challenging things for students. So we have a question here. We have 6y squared minus 18xy, and what we want to do, we want to factorize this here. So first of all, there are 4 different methods of factorizing that could potentially come in the exam, right? 4 different types of factorizing. So in this case here, we look at the 6 and the 18, and we try to see what is the HCF of 6 and 18. What's the highest number that can go into this? So the highest number that can go into 6 and 18 here is going to be 6. Then the only other thing common here is y. Now, when we look at y squared and y, we always go with the lower form of the y. So in this case here, we're going to factor out y. So this is going to be open brackets, y minus 9x. Okay? So we can always double check our answer by removing the brackets, right? So if we say 6y by y, we'll get the 6y squared. If I say, sorry, that's not 9. Where did 9 come from? Right, that should be 3. Yeah, that should be 3 there, right? So 6y by 3y, 6 by 3 will give us 6 3s are 18, and then we have xy. So that should be correct there. So these questions, you can always double check your answer. The second one, we have 4m squared minus 1. So in this case here, that's what we call the difference of two squares. So this is going to be 2m plus 1 in one bracket, 2m minus 1 in the second bracket. Okay, so that's the difference of two squares. CSEC consider this too easy, 1 mark. Next one here, we have 2t squared minus 3t minus 2. And you want to factorize this here. So this is what we call a quadratic, right? That's what we call a quadratic. Somebody say my student cooked. You better make sure I'm pass the exam tomorrow. All right, we've done a ton of work in preparation for these exams. You want to factorize 2t squared minus 3t minus 2. So first of all, when I'm doing a question like this here, what I do, I use the sum product method. So we're looking for two numbers whose sum is equal to minus 3 and whose product is equal to. So you take these two numbers here and multiply them. So that's going to be minus 4. So we're looking for two numbers such that when I multiply them, I get minus 4. And when I add them, I get minus 3. So in this case here, what can we use? If we go 1 and minus 4. So 1 by minus 4 will give us minus 4. And 1 plus minus 4 will give me minus 3. So these are my two numbers I'm looking for. So what am I going to do with those two numbers? So you're going to replace that middle term in the quadratic using these two terms here. One will be t and one will be minus 4t. The whole purpose of getting those two numbers is to get this. So what's going to happen here now, we're going to write this as 2t squared, right, plus 2t minus 4t minus 2. So once I do that, I can use factorizing by grouping in order to factorize the quadratic. So you look at the first two terms and look at the second two terms and see how best you can factorize this. So you can factor out here 2t, open brackets, t plus 1, close brackets. If I have to factorize minus 4t minus 2, I can factor out minus 2. Something looking wrong here. Hold on. Two t squared minus 3t minus 2, right? Oh, okay. I wrote something wrong. I feel I'm starting to get tired now. Right, this should have been 2t squared plus t minus 4. Okay, so this will be t, open brackets, 2t plus 1. Then this here will be minus 2, open brackets, 2t plus 1. One of the things you have to look out for in these kinds of questions here, whenever you factorize by grouping, see this bracket here and this bracket here, they have to be exactly the same. If you notice at any point those brackets are different, then something is wrong with your answer. So this is going to be 2t plus 1 in one bracket here. And in the second bracket, it's going to be made up of this t and minus 2. So this is going to be t minus 2. So that's basically what we're going to have here. Okay. Allowed to use two calculators. You can go with any amount of calculators you want in the exam. All right. They can't stop you from using two calculators. About 2 years ago, there was an issue with the Casio calculator. So just watch out for those things. All right. We have a next question here. I want to write this as a single fraction. So check this. They haven't brought one like this in a little while. So let me do one. So you want to express this as a single fraction here. When you get a question like this here, you are essentially subtracting two fractions, and you're going to look at the denominators here, which is 3 and 4. You need to find the LCM of that 3 and 4, which is going to be 12. So the lowest common multiple of 3 and 4 is 12. Now, every time I do this, some students, they get a little lost. But all you're doing here, you're taking the LCM, and you're going to first divide it by that first denominator. So 12 divided by 3, you're going to get 4. Now, what you do with that 4 is to multiply by this numerator here, right? So that 4 has to be multiplied by 5p plus 2. That's what you're doing there. You put back your minus sign because you're subtracting two fractions. Then we're going to take the 12 and we're going to divide now by this denominator here, which is 4. And in this case here, this is going to give us 3. So what's going to happen here is that you're going to take that 3 and you're going to multiply that by your numerator, which is 3p minus 1. So this is going to be 3 multiplied by 3p minus 1. Okay? Now, we need to remove the brackets on top. So you have to take the 4 and multiply by 5p plus 2. So 4 by 5 is 20. So that's 20p plus 8. Then we're going to have minus 3 by 3p, which is minus 9p. And then minus 3 by minus 3 will give us plus 3 here. Okay? And all of this is over 12. So 20p minus 9p is going to give us 11p. And then 8 plus 3, you're going to get 11. And all of that is going to be over 12. So this is a kind of question here that you kind of have to be careful with. Okay? Right? Now 1 sec here. If I'm a laptop behaving all strange. Right, give me 1 sec. My file here seems to have hung on me. Right, give me 1 sec. I'm just restarting my file here. All right, just restarting this file. Right, while I'm waiting for this file to restart here. All right, let me just give you a little piece of advice when it comes to the paper. When you all go into the exam, read the paper, read the questions carefully. Right, read the questions carefully. Take a skim through the entire paper. Take a skim through the entire paper. And then what you're going to do, you're going to choose the questions that you are comfortable with first. Okay? Don't rush and do any difficult questions first. You're going to rush to do the questions that you are comfortable first. So if you know that you can do consumer arithmetic very well, right? So if I were you, I will start with question one. I'll start with question one because that is probably one of the easiest questions to work with, right? Once you start with question one, you move from there, and then we're going to move on to, let's say, maybe the third question, right? Maybe the third question. I know some people don't like algebra, so it is totally up to you, but my advice to you is do all the questions that you are familiar with first rather than trying to do anything that is more difficult. Okay? Let's see what's happening here. Right? My file seems to be given an issue here. Yeah, technical issues. I'm not sure. Give me one sec, right? I'm just trying to restart my file here. Hopefully it comes back on. All right, the file seems to be okay now, I guess. Yeah, not sure exactly what happened there, right? So anyways, so let me just go back to this one here. So we have a formula here, and we want to determine the value of D when H is 29. So this is a very straightforward question here. You want to work out what is D. So D is given by this formula, right? All over 5. Right? That's our formula here. But H is equal to 29. So if H is equal to 29, then this is going to be 4 multiplied by 29 over 5. And we're going to find our square root here. So this is simply going to be 4 by 29 divided by 5. And we're going to work out the square root. So we're going to get 4.82. Okay, they want to answer correct to two significant figures. So hold on. Let me write that. So let me write it as 4.1866. Okay, but I want to write this correct to two significant figures. If I want to write that to two significant figures, it'll be 4.8. So that's two significant figures. So that's my answer for part 1. For part 2, you want to make H the subject of the formula. So we have D is equal to 4H over 5. And that is square root. So what you can do, you can say that D squared, if you want to get rid of a square root, you square both sides. So this becomes 4H over 5. And in this case here, you want to make H the subject of the formula. So let's write this as D squared over 1. Then what I'm going to do here, I'm going to cross multiply. So you're going to get 4H is equal to 5D squared. So if I want to get H is simply going to be 5D squared all over 4. Okay, so that's basically what we're going to get here. All right. Right, so all right, guys, so I feel like this might be a good stopping point for me, right? I feel like this might be a good stopping point for me. I think Cohen might still be online still. There's also there's another guy who's doing a live as well, forgot his name. But this is it for me for tonight, guys, right? So I've done a session this morning here about maybe 2.5 to 3 hours, and this one here is about 2.5 hours. So guys, I just want to wish you all good luck in your exams. All right, hopefully we get a good paper tomorrow, right? Somebody's asking about functions. Guys, I've done a lot of these particular topics that you all are asking for. It's on the YouTube channel, right? I've done several sessions over the last 2 weeks or so. So please go through the material, right? There are tons of videos there, right? There are tons of videos there, right? So please, there are still a few people who are live, all right? So go check them out, right? Go check them out. So good luck. Read your questions carefully, and we'll see how that paper looks tomorrow, all right? So have a good night, guys. Be safe, and I'll see you guys probably tomorrow self.